Keynotes to elevate your statistical skills, a wrap-up for medical and health researchers. Today's video is all about wrapping up some keynotes takeaways to elevate your statistical skills. The first step in elevating your statistical skills is to master the fundamentals. No matter how advanced your research becomes, a strong foundation in the basics is essential. Here's what you should focus on. 1. Descriptive statistics. Understanding measures of central tendency, mean, median, mode, variability, standard deviation, range, and how to summarize data is crucial for any research project. 2. Understanding distributions. Familiarize yourself with common distributions, like the normal distribution, as well as concepts like skewness and kurtosis, which describe the shape of your data. 3. P-values and confidence intervals. Master the meaning and interpretation of p-values and confidence intervals. They are the cornerstone of hypothesis testing and result interpretation. 4. Types of data. Know the difference between categorical, ordinal, interval, and continuous data, as this will guide your choice of statistical tests. Solidifying your grasp on these fundamental concepts will make the more advanced techniques much easier to tackle and will ensure that your research is built on a strong statistical foundation. One of the most important aspects of medical and health research is choosing the right statistical test for your data. This decision depends on your research question, the type of data you're analyzing, and your study design. Here are a few key tips. 1. Know your data. Before choosing a test, categorize your data. Are your variables categorical or continuous? Are you looking at paired or independent data? 2. Common statistical tests. For comparing means, use a t-test for 2 groups, or ANOVA for 3 or more groups. For categorical data, use a chi-square test to examine the association between categorical variables. For survival data, use Kaplan-Meier curves and Cox proportional hazards models. For relationships between variables, consider correlation or regression analysis depending on whether you're looking at simple or complex relationships. 3. Assumptions matter. Each statistical test has underlying assumptions, like normality, homoscedasticity, or independence of observations. Check these assumptions before running your analyses, and if your data violate them, consider non-parametric alternatives. Understanding which statistical test to use and why is key to drawing valid conclusions from your data. Always take time to evaluate your options based on your research question and data characteristics. Statistics isn't just about numbers, it's also about visualization. Data visualizations can help you explore your data, identify trends, and communicate your findings effectively. Here's how to make the most of visualization in your research. 1. Exploratory data analysis, EDA. Before diving into complex statistical models, start with EDA. Plot your data using histograms, scatter plots, and box plots to get a feel for the distribution, relationships, and outliers. 2. Use visuals to communicate results. When presenting your findings, use clear and intuitive visuals. For example, Kaplan-Meier curves are great for survival data, while forest plots work well for displaying the results of meta-analyses. 3. Advanced visualizations. Tools like heat maps for correlations or ROC curves for diagnostic tests can add depth to your analysis. Choose the visual that best highlights your findings without overcomplicating the message. Remember, a well-designed visualization can often communicate complex statistical ideas more clearly than raw numbers alone. Invest time in creating visuals that enhance your research story. As you gain more experience, it's important to embrace advanced statistical techniques, especially when your research demands it. Here are a few advanced methods to consider. 1. Multivariate analysis. When dealing with multiple variables, techniques like multiple regression, logistic regression, and factor analysis can help you untangle complex relationships. 2. Longitudinal data analysis. If your study involves repeated measures over time, consider techniques like mixed effects models or generalized estimating equations to account for within-subject correlations. 3. Machine learning. In the era of big data, machine learning techniques like random forests, support vector machines, and neural networks are increasingly valuable for making predictions and uncovering patterns that traditional statistical methods may miss. While advanced techniques can be powerful, they also come with increased complexity. Make sure you understand the assumptions and limitations of these methods before applying them, and don't hesitate to seek guidance if you're venturing into new territory. Finally, in the rapidly evolving field of medical and health research, continuous learning is essential. The field of biostatistics is always advancing, with new techniques and software tools emerging regularly. Here's how to stay updated. 1. Online courses and tutorials. Platforms like Coursera, edX, and Khan Academy offer free or affordable courses on biostatistics. You can also find tutorials on YouTube and dedicated research websites. 2. Books. Keep key biostatistics books handy. Classics like Medical Statistics at a Glance by Aviva Petrie and Caroline Sabin, or The Essentials of Biostatistics for Physicians, Nurses, and Clinicians by Michael J. Campbell can be invaluable. 3. Journals and conferences. Stay current by reading journals like Biostatistics, Statistics in Medicine, and Journal of Clinical Epidemiology. Attend conferences and webinars to learn from experts and see what's new in the field. 4. Software proficiency. Familiarize yourself with statistical software like R, SPSS, SAS, or Python. Each has its strengths, and learning how to code your analyses can open up new possibilities for your research. The journey to mastering biostatistics doesn't stop. Commit to continuous learning and staying updated with the latest techniques to keep your research impactful and relevant. To wrap up, here are the key takeaways for elevating your statistical skills as a medical or health researcher. 1. Master the fundamentals. Start with a strong foundation in descriptive statistics, data types, and basic statistical tests. 2. Choose the right test. Match your statistical test to your data and research question, and always check the assumptions of the tests you use. 3. Visualize your data. Use data visualization to explore and present your findings clearly and effectively. 4. Embrace advanced techniques. Don't shy away from advanced methods like multivariate analysis and machine learning when your research calls for them. 5. Commit to continuous learning. Stay current with new developments in biostatistics and continuously sharpen your skills through courses, books, and software practice. By following these steps, you'll elevate your statistical expertise and enhance the quality of your research. Thank you for joining me on this journey to mastering biostatistics in medical and health research. If you found this video helpful, don't forget to give it a thumbs up, subscribe to the channel, and share it with your colleagues. If you have any questions or topics you'd like to see in future videos, let me know in the comments. Keep learning, and I'll see you in the next video.